Hi, and welcome to the presentation for the paper SentiInc Incorporating Sentiment Information into Sentiment Transfer Without Parallel Data. I'm Karthikeya Pant, and my co-authors are Yash Verma and Radhika Mamidi. We are affiliated to the International Institute of Information Technology, Hyderabad, India. So I'd like to introduce you to the task of sentiment-to-sentiment transfer, which is essentially a style transfer task which involves changing the sentiment of the source text while reserving the underlying content. It's equivalent to finding target sentence Y that maximizes the conditional probability of Y given a source sentence X and sentiment S, which is essentially the max of P, Y given X and S. The motivation for this paper is that existing sentiment-to-sentiment transfer models ignore the valuable sentiment-specific information already present in the text. We provide a simple framework for encoding sentiment-specific information in the target sentence itself. We do so by incorporating a sentiment-based loss in the back translation-based style transfer, which is further modeled from machine translation of the similar kind. We propose SentiInc, which is a novel approach for sentiment-to-sentiment transfer, incorporating sentiment-specific information in an unsupervised setting. We claim to provide finer control over the trade-off between content preservation and sentiment transfer by having hyperparameters which you can tune in order to enforce the trade-off. And then we evaluate the performance of our model on a real-world data set, and results reveal that it outperforms the state-of-the-art methods by quite a good margin. Now, for the purpose of finding the sentiment-specific loss, we use pre-trained fast text classifiers, which provides us from polarities from -2 to 2, -2 being the most negative and 2 being the most positive, and delta t denotes the score that is predicted by the fast text classifier, and f of t is the indicator of the target sentiment. And the final loss is equal to the exponential of n square into k, where n denotes the number of epochs and k is a hyperparameter that can be tuned separately, and it is multiplied by the maximum value between 0 and f of t into delta t, as was defined earlier. Now, for ensuring that inductive transfer is followed across both the tasks of language modeling and style transfer, and also that inductive transfer is followed across the sentiment transfer, we share all the encoder and decoder parameters across the two sentiment domains to share the encoder representations, just like language modeling and back translation. And the final loss function turns out to be a sum of losses from language modeling, back translation, and sentiment specific loss. For the experiment, for our experiments, we use datasets, derivative datasets from the Yelp review dataset of two kinds. One is SYelp, which is essentially based on the assumption that each sentence in a review inherits the sentiment of the complete review. And since it was used in many of the previous works conducted in this area, we have used it to compare our approach SentiInc with various of the other state-of-the-arts that were introduced before this paper, and the BYelp, or the Big Yelp review dataset, which contains the reviews as is after minimal pre-processing. And for the evaluation purposes, we have used accuracy, which determines the efficacy of the transfer of the sentiment, and blue or self-blue for content preservation. So in this table, we see the results in accuracy, blue, and the geometric mean of both of the metrics, which is denoted by the G-score. And we see and observe that our model scores, like, beats every other model by a margin as large as 11%. And we also perform an ablation study in which we observe that uh, upon removal of the sentiment loss from our back translation based approach, we observe a drop of 0.96 in terms of G-score on the S-YELP dataset and 1.76 in terms of G-score on the B-YELP dataset, which shows that our sentiment loss is an effective method to improve the accuracy. And the blue. So concluding, we propose SentiInc, which is based on both back translation and sentiment analysis. It incorporates sentiment-based laws, which enables training through only mono-sentiment data, which converts the otherwise unsupervised task of sentiment transfer to a semi-supervised one. Our method substantially outperforms the state-of-the-art models in overall performance. As observed, we see improvements of up to 11% in terms of the geometric mean of both accuracy and blue. And future work may be converting offensive text and hate speech into polite forms, or increasing the polarity in the sentiment transfer. Thanks a lot and have a nice day.